Today we will first discuss about atomic structure. Elton atomic theory. Atom is hard, dense and smallest particle of matter. Every element has unique kind of atoms. Atoms of different elements have different properties. All the atoms of same element have same atomic mass and properties. Compounds of different elements are formed if atoms of different elements mix in a ratio of 1:1. Now we will discuss about the limitations of the Dalton atomic theory. Atom is divisible into neutron, proton and electron. That's why we can say atom is one of the smallest particle. He didn't explain about the isobar, the different elements having the same mass. For example, argon, potassium, calcium being three different elements having a mass of 40. He didn't explain about isotope, same element having different mass. Hydrogen is further categorized into protium, deuterium and tritium having different masses, i.e. 1, 2, 3. But the element is same. Now we will discuss about the discovery of cathode. It is done by J.J. Thomson. Cathode rays are made up of negatively charged particles called electrons. They travel in straight line path. Cathode rays affected in presence of electric field and magnetic field. Properties of cathode rays and or electrons remain same even if we change the electrode or gas present in the discharge tube. Material required: discharge tube, 100 voltage generator, 0.0001 atm vacuum, 1 atm or the pressure, the discharge tube, vacuum pump, cathode, anode, connecting wire, fluorescence material. Fluorescence material used in it will be the zinc sulfide. Now we will discuss about the watermelon model or the prince pudding model. Atom is a sphere of positively charged particle and electrons are embedded. This is given by J.J. Thomson. Now we will discuss about the Rutherford experiment. He took alpha particles, nucleus of helium, and passed them from a thin gold sheet. Observation: most of the alpha particles was undeflected. Some of the alpha particles undergo deflection by the small angle. Very few particles, 1 in 20,000, undergo deflection by large angles, i.e. 180 degrees. Conclusion is that most of the alpha particles of an atom is empty. There should be some positively charged in an atom. There should be some heavy part in an atom which is confined in small area. This heavy particle is called nucleus. Electrons revolve around the nucleus. Now we will discuss about the limitations of the Rutherford experiment. He failed to explain the Maxwell theory, stability of an atom. What is the Maxwell theory? If electron revolve in a circular orbit, it emits radiation due to which energy of electrons is continuously decreased, so it finally falls into the nucleus. Now comes the Niels Henrik David Bohr. He explained the Maxwell theory. He explained that the electrostatic force between the proton and electron provides the necessary centripetal force to electron for revolving in a circular path. He gives the formula of C equals to mv square upon r. Electrons can revolve in a fixed number of orbits. While revolving in these orbits, electrons have fixed velocity and fixed energy. Electron will revolve in orbit in which angular momentum is integral multiple of h upon 2 pi. He derived three formulas. Radius of orbit equals to 0.53 n square by z angstrom. Velocity of an electron is 2.18 into 10 to the power 6 z by n meter per second. Energy of electrons is equal to minus 13.6 z square by n square equals to electron in its unit will be electron volt per atom. Electron can accept or release energy if it jumps to another orbit after accepting or releasing energy. Bohr's model is only applicable for hydrogen-like species, i.e. we can say it is only applicable for the single electron species. Now we will discuss about the limitations of the Bohr's model. It is not applicable for multi-electron species. It will explain the Stark effect, splitting of the spectral line in presence of electrical field. Didn't explain the Zeeman effect. What is Zeeman effect? Splitting of spectral lines in presence of magnetic field. He also didn't explain the dual nature of electrons. What is the dual nature of electrons? Sometimes behave as a particle and sometimes behave as a wave. Now we will discuss about the Planck's quantum theory. Energy is produced discontinuously in form of discrete energy packets called quanta or protons. He derived the formula if E equals to hv. Here h is equals to Planck's constant, which is 6.63 into 10 to the power minus 34 joule per second, whereas V equals to frequency. Now here are different types of rays. First comes the cosmic rays, gamma rays, X-rays, ultraviolet rays, visible rays, infrared rays, microwave, and now we will discuss about the Hensburg uncertainty principle. It is impossible to measure simultaneously the position and momentum microscopic object with absolute accuracy. Here delta x is the uncertainty in position, whereas the delta p is uncertainty in momentum. Therefore delta x into delta p will be always greater than or equal to h upon 4 pi. Now we will discuss about the quantum mechanical model of an atom. Here we will define orbital. Orbital, it is a 3D space around nucleus where the probability of finding electron is maximum. It follows the Heisenberg uncertainty principle based on principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum. Rules for filling the subshell is, first of the rule is Aufbau's principle, then comes the n plus L rule, then comes the Hunt rules, also known as multiplicity, then comes the Pauli's exclusion principle. That's all for today. Thank you.